There are many different groups of crustaceans. They're divided up into more than 20 orders. We won't have time to go over all of those, so we're going to focus on just 3 orders. The decapods, which include the true crabs, lobsters, and shrimp. The isopods, which include the pillbugs or roly-polies. And the copepods, which are small planktonic crustaceans. So let's start with the decapods. Again, this group includes the lobsters and all the lobster-like animals, crayfish, shrimp, and prawns, and the true crabs. The name decapod comes from the number of walking legs they have. Deca means 10, think decade. And pod means leg, so decapod means 10 legs. You can see that we're counting the claws here, because again, these are just modified biramus legs. The technical term for these claws are chellae. In decapods, the first pair of walking legs, closest to the head, are modified into chellae. Decapods also have the head and thorax fused into a cephalothorax, so they have 2 tagma, the cephalothorax and the abdomen. In the abdomen, we don't have walking legs, but we do have appendages modified into pelopods or swimmerets. These are specialized for swimming and work like little tiny paddles. At the end of the abdomen, we have this fan-like tail that's made up of 3 parts. In the center, we have an extension called the telson. On either side of the telson are another pair of modified appendages called uropods. These are basically large pelopods. Together, the telson and the uropods function similar to the tail of dolphins or whales for swimming. If you've ever eaten crabs in the shell, you've probably noticed their exoskeleton is very hard, much harder than that of insects. Just imagine if you were driving and some crabs hit your windshield instead of insects. They'd probably bounce off instead of splatting and might even cause damage. The reason the exoskeleton is so hard is it's not just made up of chitin. It also contains calcium carbonate. This is the same compound that made up the hard exoskeleton of corals. So this hard exoskeleton gives decapods protection from predators, and also from the strong forces of waves and tides if they're living in the intertidal zone of the ocean. In the crabs, the anatomy is a little different from lobsters, shrimp, and prawns. It may not look like it at first glance, but crabs do have a cephalothorax and an abdomen. The abdomen is just tucked up under the cephalothorax. You can actually tell the sex of a crab by taking a look at the abdomen. In females, it's much wider than in males. This is because when they lay eggs, they carry those eggs under the abdomen until they hatch. I referred to the crabs in the order Decapoda as true crabs. This is because there's other crustaceans in different orders that look very similar to true crabs, but they evolved this body shape completely independently. In fact, the general crab body shape has evolved on its own at least 5 times within the Crustacea. How wild is that? There's a name for this phenomenon, carcinization. If that sounds like carcinogen, there's a reason. Crabs are the symbol for the zodiac sign Cancer, and Cancer comes from the Latin root that means crab. So carcinization is basically crabization. This is an example of convergent evolution, where multiple species evolve similar characteristics independently of one another because they're responding to similar selective pressures in the environment. So this body shape is just highly advantageous in aquatic environments, leading many crustaceans to evolve in a very similar way. If you want to learn more about this, here's a video talking a little bit more about carcinization and why that crab body form is so advantageous. And probably my favorite decapod is the hermit crab. which you may know use snail shells as shelters that they carry around with them. Here on the left is what a hermit crab looks like out of its shell. The abdomen is coiled to fit up into that coiled snail shell. As a crab molts and grows, it needs to move into a larger and larger shell. And hermit crabs sometimes exchange shells or fight each other for shells. You can see some of that behavior if you watch this video. Most decapods are aquatic, but there are many terrestrial species as well. If you've ever kept hermit crabs, you know that many of them are terrestrial or semi-terrestrial. But this crab here is a wild example of a terrestrial crustacean. This is the coconut crab, which is the largest land invertebrate in the world. It lives not only on land, but up in trees, where it hunts its prey. You can't see just how big this animal is from this picture, but just wait for the next slide. Here we go, an absolutely huge crustacean. They can grow to have a leg span of 3 feet and weigh up to 9 pounds. They do eat coconuts, hence the name, but they're also predators and scavengers. And they can sometimes take down pretty large prey, like this crab taking down a large bird. We actually have some terrestrial decapods here in West Virginia as well. While most crayfish are aquatic, some are terrestrial or semi-terrestrial. There's a species found in West Virginia that mostly lives on land. They often burrow near ponds and creeks and create these little mud chimneys as they dig. So look for evidence of crayfish next time you're hiking near a body of water. Decapods can play many different roles in the food web. Most are scavengers, so they're eating and cleaning up dead things. Many are predators, actively hunting prey with those chelae or claws. But there are some that are herbivores as well. And they're a really important food source for larger animals. Water birds and aquatic mammals rely heavily on decapods for food. And here you can see a baleen whale feeding on a swarm of krill, which are like tiny shrimp-like decapods. Even though they're tiny, krill are very abundant in the ocean and make up a large part of the diet for baleen whales. Now let's move on to our next order, the isopoda. You may know these guys as roly-polies, pillbugs, sowbugs, or woodlice. Isopods can either be terrestrial or aquatic. You're probably more familiar with the terrestrial ones, but we'll see some examples of aquatic ones as well. They have 2 tagma, a cephalothorax and an abdomen, although even the separation between the cephalothorax and abdomen is a little hard to see. They have walking legs on both the cephalothorax and the abdomen. And those legs are usually of similar size to each other. This is where the name isopod comes from. Iso means equal, so equal leg. Some of the aquatic species will also have pelepods for swimming. Many of the terrestrial species are able to roll up into a ball, protecting their softer underside and only exposing the tougher upper part of their exoskeleton. This can serve 2 purposes. One, it's a great defense against predators. You may have noticed pillbugs doing this if you try to pick them up. But it can also help prevent water loss when it gets dry. Water is more likely to evaporate out from the underside of their body, which is also where their gills are. Because yes, they breathe on land using gills. So when it's dry, they can curl up to reduce that evaporation. Most isopods are small, but there's some marine species that can get very large. This video will show you a crazy example of a huge marine isopod, and I highly suggest watching it because it's a really cool animal. Most isopods are scavengers or detritivores. But I want to tell you about one parasitic species that's pretty interesting and terrifying at the same time. Seriously, you just have to watch this video to believe it. And if you like bee horror movies, there's a movie based on this isopod called The Bay, and it's both terrible and amazing. Isopods can come in a wide range of different colors and patterns, and because of this, they've become very popular in the pet trade, especially in the last 5 years or so. So if you think these guys are cute and want some easy pets that can live in a plastic shoebox under your bed, you might want to check out isopods. Okay, the last order we're going to talk about are the copepods. They're very small crustaceans that are usually planktonic. While there's a lot of variation in how they look, most of them have this kind of teardrop shape, with a long pair of appendages that work like oars for swimming. They usually also have a single compound eye in the center of their head, which is usually red. So they're like tiny little cyclopses. Because they're so small, they don't even need gills. They just take in oxygen through diffusion right through the exoskeleton. That description sounded familiar. You may have been picturing Plankton from SpongeBob, who is a copepod. You can see that single red eye and the teardrop shape. They made the oar-like legs look a little more like antennae in the cartoon. If he were an accurate copepod, he would obviously not have arms and legs, and would move by swimming with those appendages on his head. If you want to see an actual copepod in action, check out this video. While they're small, copepods are very abundant in most aquatic systems. When we talk about plankton, usually a lot of that is made up of copepods. They feed on other planktonic organisms, mostly phytoplankton, the plant-like plankton. And like the krill we talked about, they're really important food sources for many larger animals, including baleen whales. Because they eat other tiny aquatic organisms, they can also help clean up drinking water. New York City doesn't filter its drinking water, and copepods can survive the chemicals used to treat the water. Because of this, there are actually copepods in the water when it comes out of the tap. But they can be helpful because they eat mosquito larvae, which we definitely don't want growing in our tap water. Interesting enough, though, it means that New York City drinking water is neither vegan nor kosher if it's not filtered. But most people have no idea they're drinking tiny crustaceans every day. I want to tell you about one last cool crustacean, which is not in any of the orders we just talked about, even though it looks very shrimp-like. The mantis shrimp is fascinating because it can see more colors than any other animal we know of. It also has extremely powerful modified legs that it uses to punch its prey. This species went viral on the internet several years ago, so you may have seen videos of them before. If not, check this out.